It's time to talk turkey about 10 gigabit Ethernet. Before we get into that, just so you know, this is really part 2, the second video in the series. If you haven't seen the first video in the series, it's more of a basic overview of 10 gigabit, why you'd want it, how it works, some of the challenges in the engineering. I would encourage you to check out the first part, which is linked to in the description. This video is going to be more about the Netgear XS712T Ethernet switch and some of the features that you can get through the web GUI. So let's start with our Netgear switch. Now, these are expensive for an individual. If you're thinking about running 10 gigabit at home, let me suggest that maybe this is not, the prices have been falling, but this is probably not the best choice for you. There are other options out there though. Netgear has a couple of 24 port gigabit switches that have SFP plus uplink ports. And so that means that you've got, you know, 2 of these SFP plus slots. So you'll have to get some kind of adapter, either the copper adapters or the fiber optic adapters if you have the Intel NICs that have the built-in fiber optic option, so that you can have your server with a 10 gigabit interface, and then all of your workstations would then have the 1 gig interface. Or your workstations could even, you know, most motherboards have 2 NICs, and if you've got 2 onboard Intel NICs, you could bond those, and then your workstation would be able to do 200 megabytes per second on the bonded connection. Theoretically, if the sun and the moon are aligned and you sort of jump through some hoops on your network and do a few other things, then you can get the maximum throughput with that. For our purposes though, it will be easier to just roll with the 10 gig. Now this switch, this is the 12 port version. There is also an 8 port version and a 24 port version. And this is not really exactly enterprise gear. This is really transitional gear that's aimed at, you know, a small business that wants serious Ethernet performance, but does not necessarily want to shell out, you know, multiple thousands of dollars for 10 gigabit Ethernet equipment. Now, of course, Netgear and other companies do have more enterprisey 10 gigabit gear, but the middle of the road 10 gigabit gear in the enterprise market typically starts around $3,500. Now, in terms of features though, I've been really impressed with this. After having used it for a couple of months, I've thrown a lot of stuff at it, and it's been really impressive. It's been really performant. I've been very satisfied with everything about it. It's got VLAN support, it's got quality of service support, it's got automatic denial of service protection, so in case you accidentally plug the network into itself, it's like, oh, you're a dumbass, let's just ignore that. It's got troubleshooting options and built-in cable tests, so if you have something that's iffy, you can go in the web UI and do a cable test and actually find out if it's your cabling. With 10 gigabit, the cabling situation is such that if you've got Cat 6, you can run about 30 meters or about 100 feet on your connection with that at 10 gigabit. More than that, it's probably not going to work. If you've got Cat 6A or Cat 7, you can get the full 100 meter runs out of your network infrastructure. But I'm betting that most people that are working in, you know, a typical office building or a typical small business probably did not wire with Cat 6A or Cat 7, which until very recently was just comically expensive. But if you do have Cat 6A or Cat 7, or you're getting ready to wire an office, say you're building an office and you're not using Cat 6A or Cat 7, that's probably silly, because Cat 6 is only going to carry 10 gigabit for about 100 feet. And when you're going up and down walls, 100 feet really doesn't last you very long. This has got IGMP snooping for improved multicast optimization. It's got port trunking, of course, which is the link aggregation stuff I was talking about before. Port mirroring. Port mirroring is useful for network monitoring, so you can do packet capture and see what's going on a particular port. Like you could mirror the port that your server uses and then do a packet capture to see what all your server sees without actually having to install packet capture on your server, for example. It's a really useful troubleshooting tool. Of course, it's got jumbo frame support. Jumbo frames, that's another thing that we need to have a conversation about, because if you're going to deploy a really high performance network, you probably need jumbo frames. CPU speeds have gotten to the point where jumbo frames are not as necessary as they once were with gigabit Ethernet. If you're moving, you know, when gigabit Ethernet first came out, it was the same situation. The CPUs and computers really just couldn't keep up. Multi-core wasn't really a thing yet in the workstation, but it was in the server, multiple sockets in the server. And so jumbo frames were seen as a way to deal with the overhead of the fact that the CPUs really couldn't handle it's not really the amount of traffic, it's sort of the overhead. So imagine that you've got with 10 gigabit, imagine that you've got all the text in the Library of Congress that you need to send to A to B, and our intern Randy is going to help with that. So Randy is going to deal with all of that information in the Library of Congress at superhuman speeds, because, you know, Randy's amazing. He's going to deal with it one sheet of paper at a time. So every book, everything, everywhere is going to be dealt with one sheet of paper at a time. So it's Randy, go get me all the text that's in the Library of Congress. Randy is, his cousin is the Flash. So he's going to be able to do that at basically superluminal speeds. But then I've got a pile of crap in my office that is every page from every book in the Library of Congress, and I've got to deal with that. So obviously that's not very productive. That's kind of the situation with 10 gigabit Ethernet and regular Ethernet frames. An Ethernet frame is the largest amount of information that can be sent over an Ethernet connection. Historically, that has been 1500 bytes. So when your computer wants to send a file from A to B, or when you're downloading a file over the internet, that file is broken up into 1500 byte packets. And that's called an MTU, a maximum transmissible unit. What Jumbo Frames does is allow you to bump up the limit. Typically a Jumbo Frame is 9,000 bytes, or, well, depending on how you count it, it's 9,000 bytes or 9028 bytes or 9140 bytes, something like that, depending on how you count overhead and some other things. The problem is that it's very difficult to mix MTUs. There are algorithms that try to discover MTUs, but almost all of them are universally bad. To save yourself a lot of headache and insanity, I would suggest that if you're going to use Jumbo Frames, that you either set up a separate storage network or a separate storage VLAN, which is like a separate storage network that will carry all of the Jumbo Frame traffic. Now, of course, our Netgear XS712 supports Jumbo Frames. Pretty much even gigabit switches of anything of the last 6 or 7 years supports Jumbo Frames. If you don't mind having a separate storage network, if that does not cause you a lot of headache, having a separate storage network with Jumbo Frames is generally more performant. There are situations where it is not as performant as having a 1500 byte frame. This is typically owing to driver optimizations, especially on some platforms with some network cards. And so if you're running Linux or FreeBSD and you've got kind of a sketchy network adapter and you're running Jumbo Frames, it may actually be slower, at least at gigabit speeds, than running 1500 byte frames. Typically you can make that go away if you're willing to tune it yourself, because maybe the drivers have brain dead tuning, like the buffers or something are set weird and you just have to fix it. But if you don't want to fiddle with it and your gigabit 1500 byte frames, you're clearing 100 megabytes per second on gigabit, don't even bother. It's completely fine. But on 10 gigabit, because CPUs are slower and because the hardware doesn't really support it and blah blah blah, Jumbo Frames actually do help a lot. It helps lower the overhead, because instead of having Randy send me 1 page at a time, Randy's going to send me about 7 pages at a time, and that is going to dramatically, it doesn't sound like much, but that's going to dramatically shrink the amount of reassembly that I have to do when Randy delivers me the entire text of the Library of Congress in about 4 seconds. So keep that in mind. Now, the only real complaint that I've had in using the XS712T is that it doesn't have a serial console, or it doesn't seem to have the ability for SSH for remote access either. Now inside, there was this unidentified port. I'm not really sure what it is. It's probably an RS-232 port, but it's not meant to be user accessible. So I guess we'll let that go. If it did have SSH or an RS-232 port, there really wouldn't be a lot to differentiate this from stuff that's more at the enterprise level. Because of the VLAN support, because of the great performance with iSCSI and Fiber Channel over Ethernet and other tests that we've been doing, low latency, that sort of thing, I think that Netgear was worried about sort of cannibalizing their enterprise market. So this switch is aimed at businesses that are not going to necessarily deploy, dozens or hundreds of these, because if you're going to deploy dozens or hundreds of these, remote access, not through a web interface, is probably what you need. It does have other features that make administering it really easy though. It does have, you can download a textual version of the configuration. So once you get your configuration set up, if you're going to deploy a lot of these, you can actually use the web UI and upload the configuration. The only thing that's strange about that is the web UI flips the meaning of upload and download. When you're going to fetch the configuration from the switch, you are uploading it to yourself in the switch's vernacular. When you are going to send the configuration from your local machine to the switch, you are going to have the switch download the information through the browser. That seems weird to me. I guess depending on how you look at it, the terminology is not wrong. If it's from the switch's perspective, the switch is going to upload the configuration to you and download the configuration from you. I guess it's okay, but it seems weird that the terminology is backwards. I guess they expect everybody to use like a TFTP server. Instead of using the web browser, you're going to tell the switch, hey, upload it to this TFTP server, or hey, download your configuration from this TFTP server. But it's a full text configuration file, so if it looks like a pretty standard format, so you can actually go in there and fiddle with things and upload it and see if anything goes wrong. But I was sort of impressed with that. It does come with an Adobe Air configuration utility, but you totally don't have to use the Adobe Air configuration utility. You can totally use the web-based configuration utility, which is what I did pretty much all of the time. There were a few options that were really easy to get to in the Adobe Air configuration utility that were harder to get to in the web interface, but I think that's just because the web interface has a lot more configuration options than the Adobe Air interface. And the Adobe Air interface has you know, a link to take you to the web interface for the more advanced functions anyway. So the Adobe Air option may make it easier if you're deploying 5 or 10 of these. You could theoretically manage them this way, and it wouldn't be too much of a headache. So we've logged into the switch. There's a lot of options. It's really, I mean, this is really what I would expect for something from, you know, the higher end. I mean, this really is a high-end option. There's just no SSH or RS-232, which is unfortunate. I'll also say that it's quieter than I expected. When it gets under load, it can get quite loud. It basically runs at 50 to 55 degrees all the time, which seems a little warm to me, but when the Switch first came out with very early versions of the Switch firmware, the fans were running all the time, and the fans can get very loud. And so I think that the Netgear sort of saw that and said, well, you know, the ratings on this hardware, it can actually take the heat, so let's slow the fans down so it's not so loud all the time. If you have the Switch and you're running multiple ports at full speed for an extended period of time, or with cable runs that approach the full, you know, 100 meters, a significant amount of heat will be produced. And internally, if you didn't see the teardown video, the thing is basically entirely a heat sink. Like when you take it apart, it's like, wow, the entire thing here is a heatsink. You could probably get $200 recycling aluminum out of it. It's crazy. So inside the web UI, we do have full support for IPv6. I did not do a lot of IPv6 testing, by the way. IPv6 is still a little too new. It does support SNMP. SNMP stands for Simple Network Management Protocol. It does support SNMP v3, which of course has encryption and hashing, which are nice features. It also supports LLDP and lets you configure LLDP policies, and of course all of this will download through the configuration options. And so these are really nice features. And then there's a services option that lets you see information about DHCP leases as they're passed out from the DHCP server. And so this is sort of a neat feature where the switch can actually snoop on your DHCP server to see which IP addresses are associated with which ports automatically. So normally the way that you would do that is you'd have to do an ARP lookup and then sort of deal with that and say this MAC address is on this port, and I got that by pinging it. And sometimes that's tricky to do because when you're pinging it, you're going through a subnet and then you get the gateway to that subnet, but not the actual machine in the subnet. And so this makes life a little easier when you've got more than one switch in your organization and more than one subnet. Now, in terms of switching, the switch configuration and all of the other options, this is really cool. You can set the maximum frame size on a port by port basis. You can also configure multiple VLANs. So if you wanted to have two VLANs or two virtual LANs, one with 1500 byte MTUs and the other one with the jumbo frames, the 9K or 9000 byte MTUs, you totally could do that with this hardware. That's what I did for experimental purposes, and basically it worked fine. This is nice because you can have, you know, a 10 gigabit interface that's basically an uplink to the rest of your LAN operating on the 1500 byte MTUs for compatibility, but then your storage network can continue to operate at 10 gigabit. So this way you can have a single 10 gigabit interface in your storage server, but that single 10 gigabit interface in the storage server is hooked up to two VLANs. One that's your local storage VLAN, and the other one that's the rest of your network. That way you don't actually physically have to have two interfaces in your storage server unless it's just more convenient for you to do that. That way the rest of the computers on your network can get to the server computer. It's just going to be at, you know, gigabit speeds. If you've got another switch, because remember I mentioned this might be a core switch, if you've got another switch that has, you know, 24 gigabit ports, and then you've got the two SFP plus 10 gigabit uplink ports, you could connect one of those to this switch, do the VLAN stuff, and then up to 10 of those workstations on your 24 port gigabit switch can be communicating with your 10 gig server at 10 gig speeds. There will be no contention until you've gotten, you know, around or past that a theoretical 10 gig limit. So this is a really good way to mix older hardware and older workflows with newer hardware and newer workflows while having, 10 gigabit and 1 gigabit safely on the same network, but in multiple VLANs. We've also got support for 802.3x global flow control. This helps the network sort of function in a more healthy way, so that if you do have a few clients on your network that are moving files at 700 megabytes per second, you don't get in a situation where the people moving files at 700 megabytes per second are starving resources from everybody in the peanut gallery with only their 1 gigabit connections. That way you don't really, have a slowdown for those people. The people that are moving at 700 megabytes per second will be perfectly fine to move their file at 600 megabytes per second, while whoever is able to do whatever else they need to do. Now, one thing that I was really impressed with on this switch when we were doing iSCSI testing and latency testing, let me just spoil it for you right now. We were getting north of 250,000 IOPS per second, close to 300,000 IOPS per second in some cases. This is for 4K random IO, basically to a RAM disk. Not exactly, it was not exactly a RAM disk, but basically to a RAM disk on the host system. This is crazy. Their advertised latency for the 10 gig base T, that's the copper interfaces, is about 6.6 microseconds. And the latency for SFP Plus is about 2.79 microseconds. Now, this is less than 1 millisecond. So in milliseconds, it's 0.66 milliseconds on the one and 0.279 milliseconds for the SFP Plus interface. That's really fast. A lot of the time, especially when you're talking about iSCSI storage, let's say that you're building a quote-unquote cheap, because nothing's cheap with VMware, VMware solution, and you're using iSCSI for your storage. If you've got redundant paths, meaning that you've got two of these switches, because this switch doesn't have a redundant power supply or anything like that, you wouldn't expect it to at this price point either, then you could actually run two of these switches and have that be part of the fabric for your storage option. So if one of the switches conks out or dies or whatever, the other one will still let your VMware virtual machines go through iSCSI through the other initiator to get to your storage setup. But this kind of low latency, I mean, I gotta tell you, there are other vendors that are pushing special low latency options on the 10 gig side for traffic that is primarily iSCSI. This thing was basically good to go out of the box for all of that. And so that was kind of surprising, because we've tested other 10 gig switches and, the latency through the 10 gig interface on the order of, 1.5 milliseconds, which is not terrible, but it's kind of bad when it's, iSCSI. You don't really want that for your storage, because that's going to kill your IOPS. Now, for the testing that we did, that was a 16 thread benchmark, and so we're talking about 16 streams reading and writing from iSCSI storage. So it's sort of a best case scenario, but holy crap, it was fast. Also happy to report that this switch has routing support. So if you want to use the switch as a basic router to forward traffic between interfaces or forward traffic between VLANs, you can. There are not really a lot of options for configuring how the traffic flows, so you're not going to get, packet filtering or anything like that, at least not advanced packet filtering, but it actually works pretty well. For quality of service, we've got several options for class of service detection. You've got class of service detection in 802.1p or DSCP, and you can set that on a port by port basis, or you can set a global option as well. Class of service is important because let's say that you're running VoIP on a network, or your surveillance system is an IP-based surveillance system, so you're delivering high definition video, for example. High definition video, it's not unusual these days to have security cameras, for example, that are streaming 1920 by 1080 at 15 frames per second. That's a significant amount of bandwidth when you're talking about 10, 20 cameras. This class of service, when you're dealing with security cameras, will let you prioritize the situation such that those voice over IP phones, which is a negligible amount of bandwidth, or those cameras are never starved out, because the cameras will never really be able to retransmit the video. They're just sending the video to the storage server and hoping it gets there. The cameras themselves typically don't have very much of a buffer or very much of an ability to resend packets. And so if they are starved out because, again, the crazy person is moving, multiple terabytes of video to your storage server, you get in a situation where maybe that starves out the security cameras, or maybe that starves out the voice over IP system for bandwidth. Well, by using VLANs and class of service, you can prioritize those classes of service ahead of other classes of service. This is really important if you have multiple things like that running on your network. There are a lot of options for security on this switch, and I think that it would probably be worthwhile to do a separate video on networking and network security. You should know that the general classes of options that are available, it does support radius, it does support TACACS. I've only ever seen that written. I've never heard anybody try to pronounce that, so I'm not sure if it would be a TAC ACS or, I'm not really sure. What these features do in conjunction with port-based authentication and traffic control and that sort of thing, you can have your network set up so that the MAC addresses that it's seen before are basically trusted and put on a trusted VLAN. But any MAC addresses that have not been seen before are put on another VLAN that's not necessarily trusted and doesn't have access to anything. You can store who has access to what, either by like having a radius logon server. You can also do a sort of port-based IPsec type security option where all of the traffic is basically encrypted and the switch doesn't even know what is going on, and if the keys all check out, then the traffic will be forwarded to the appropriate VLAN, otherwise it wouldn't be. So this switch supports 802.1x for port-based authentication, for the VLAN assignment, for dynamic VLAN creation, and it supports the EA-PAL flood mode options as well. For port-based authentication, you're able to specify what the guest VLAN is and what the unauthenticated VLAN is and how periodic you want the reauthentication to occur. You're also able to use the system to set ACL-based authentication, and so you can assign these things based on rules around not just the source MAC address, but also the destination MAC address, or the destination IPv4 address, or the destination IPv6 address, and a whole lot of options. So in terms of security, these are the things that you would need if you were using this as sort of a 10 gigabit core switch. If you had multiple, say, gigabit switches, or you had multiple gigabit switches with 10 gig uplinks, and you've got a few servers that have 10 gig interfaces, you can use these to really fine-grain control your network. Of course, for monitoring, you're able to monitor all the information, not just at a switch level, but also an individual port level, number of packets, bytes passed, how long the interface has been up, whether or not there have been any errors. And there's also this handy built-in cable tester. 10 gigabit is so fast and requires the margins to be so tight on everything. Even if you're using Cat6, if you didn't use top shelf connectors, or you didn't use a top shelf patch panel when the Cat6 network was deployed, there are going to be errors. And so it's really important that you spend time, especially if you deploy a piece of equipment like this and you're upgrading existing infrastructure, that you spend time looking at these options, looking at these reports and statistics to figure out if you've got any problems. It may be that port 7 is producing some significant errors. It may be worth looking at the cabling situation on port 7. Maybe the people that were wiring ran out of Cat 6 and they went for Cat 5e for just that one run, or maybe that port was put in later and it was Cat 5e. These are the kinds of things that I've uncovered doing, just sort of babysitting these kinds of things, and you'd be surprised what's out there. Of course, if you're using Cat 6a or Cat 7, you're probably in better shape because the controls around those standards are a little tighter. But if you're on Cat 6, Cat 6 is kind of on the fence. Cat 6 will run 10 gigabit, but only up to about 100 feet. And then after that, you're really pushing your luck because there's not enough signal compared to the noise that Cat 6 picks up beyond 100 feet or 30 meters. And of course, you've got maintenance options for doing a device reboot, factory reset, uploading new firmware, that sort of thing. In fact, we're actually behind on firmware right now, so we can actually upload firmware. Now, firmware, it can be uploaded through a TFTP server, which is completely an option. We are going to use the Smart Control Center because I don't know why. Again, here are the options you can upload and download. The labeling is sort of the reverse of what you would assume. When you download the configuration, you are having the switch get a configuration from you. And when you upload the configuration, you are having the switch send you a configuration. So that's kind of weird, kind of backwards from what you would expect, but it's the switch's perspective. It's not your perspective, it's the switch's perspective. Primary storage, run this firmware after download. Sounds good to me. It's like, oh, and if you're wondering, what does he keep looking at up there? For me, the screen that's over here for you guys is there for me. So it's the second row of monitors. File transfer completed. Waiting for device to reboot. that's the story of my life. About 30 seconds, I'm going to get a call. Is the server up? Is the server down? I was doing a thing, and there was a thing, and server's down, and I don't know what's going on. And in fact, I did. Just now. On my phone. I like the people that are like, let me send you a text message because that's not as terrible as a call. And it's like, but it's still not a weekday, and why is this happening? System administrators in the audience feel my pain, I'm sure. Or DevOps people, or developers trying to work on a Sunday. It's like that asshole DevOps guy. But took everything down again. I don't know if it's done or not. I didn't click on the right thing. Clearly something's happening. If we had a serial console, we could see what was going on. Looks like we're back up. Yeah, 6.1.33. It was on 6.1.30, so this is cool. There've actually, in the time that I've been testing this, there have been several firmware upgrades, mostly bug fixes, things like configuration changes, that sort of thing. That's been nice that it has been a well-supported product. You know, honestly, I've been really impressed with this in terms of the value. I mean, it's not... It really straddles the line. It has a lot of the features that you would expect from an enterprise class switch, but the pricing is not enterprise class. It's more than you would want to spend on a home setup. On a home setup, you really wouldn't need more than the link aggregated 4 individual gigabit connections that I was talking about before. But for a smaller medium business or an operation where you've got a lot of people that are working with a lot of very large files, moving it in and out of a storage server, this is really a really good choice. I'm really impressed with how quiet it is as well. I mean, that shouldn't really be a factor for rack mount equipment. But if you're going to use this, you know, in Soho, or you're going to, you guys in downtown Manhattan with your little hipster video studio or whatever, and this is going to be on a table somewhere, this would actually work really well without being really disturbing. I mean, I guess if you go into a video shoot and then everybody's dumping all their footage from their, you know, red 4K cameras, the fans probably would kick up and you probably would hear a little bit of a noise while you're doing that. Maybe you would hear a little bit of a noise while you're working, but by and large, I've been doing those kinds of tests and it's basically been okay. I hear it ramp up every now and then, but it really hasn't been bad. And it's been maybe 15 or 20 feet away from me. So not really too crazy. The warranty and the support on this is also nice. It's a ProSafe lifetime warranty, but you've got Pro support, which is 24/7 support for configuration issues and sort of customer installation for the first year. This is an example of one of the configuration files downloaded through the web interface. Now, of course, you can download this through that Adobe Air application as well. I downloaded this through the web UI. There's no configuration here at all, really just some comments. It's got the automatic audio video VLAN. There is also a VoIP VLAN, which is a VLAN 2, but I think the configuration for that is provided in the firmware, and the audio video VLAN is provided later, like in a startup script or something, which is why it shows up here. Otherwise, I'm not sure why VLAN name 2 is not showing up in the configuration, but I don't think that that's anything to worry about. So for the last several months, this switch has been my test bed in testing Linux and FreeBSD, FreeNAS specifically, but you know, FreeBSD, kernel tuning and kernel parameters, and also it has been my core switch for doing tests of 10 gigabit. Now in the office, we have Dell 10 gigabit switches, and that's what I've sort of interfaced it with through the SFP Plus interface. The Dell switches are quite a bit more expensive, let me tell you. And the Netgear has actually performed as well or better than the Dells. Honestly, the only thing that the Dells have that the Netgear switch doesn't is remote console, serial console, and redundant power supplies. Those three features are really it in terms of VLAN coverage, in terms of port aggregation, in terms of port control, in terms of port security, MAC address security, routing. I found feature parity with the Dell switches, the higher end enterprise Dell switches, which start at about $3,600, and that's with a discount. I think retail, they start, like their advertised price is around $4,200 a switch. This thing gives those a run for its money. I've been very, very impressed. The Dells internally are not, you know, a giant block of heatsink. The Dells don't seem to run quite as hot, but the fans in this Netgear will cool it down if it gets hot, and you will hear it. It sounds like a vacuum cleaner. But most of the time you don't really hear it. Most of the time, unless you're running most of the ports at full speed, you're not even really going to hear the fans kick up. Overall, I've been really impressed with this, and this is the core piece of equipment that we are going to be using for all of our diagnostics and coverages and guides for setting everything else up. So you've got Windows Storage Server 2012 R2 to look forward to. You've got FreeBSD, super crazy performance tuning coming up. You've got other options for Logan's NAS, because of where he is and because he's not going to have a whole bunch of editors. We're actually going to go with the multi-gigabit port thing because that's easier. He needs more devices, and so we're just going to do link aggregation for that. Here, because I have some other things in mind, and because we want it to run like greased lightning, we're going to demo all of the setups with the full 10 gig interface. It is possible that once we've got a couple of editors going at Logan's place, that we will upgrade his NAS from what it is to 10 gig, but it may actually be the case that we just build another NAS and then use that one for replication and storage and that kind of thing. The nice thing is that you can clear 2 gigabytes per second, even on a single file transfer with the right setup. And you can do it without having the entire NAS made up of SSDs. You can use the SSDs for caching, for reads and writes, and then have everything else backed by mechanical storage. It's a fraction of the price, and it's a pretty good hybrid setup. So you stuck with me this long, but you've got to be thinking, what does it really mean for 10 gigabit, the whole multi-core thing? How does that actually work? Well, it turns out that higher end 10 gigabit cards actually implement multiple hardware receive queues, and that means that it can receive multiple streams from multiple computers efficiently and spread the load across multiple cores. And so it would be like, you know, Randy is bringing me stuff from the Library of Congress at superluminal speeds, but there's actually 3 of me, and Randy knows that, okay, A through F is this guy, F through whatever is this other guy, and finally whatever through Z is the third guy. And so Randy knows to deliver it to the appropriate queues. It's kind of like that. And so what you can do to really easily support this quickly, like what's a dirty hack? How do you do this? Well, you can combine 2 things. So let's say that your server's name on the network was server. Well, what converts the name server into the IP address? Well, DNS. And so this is why it's critically important to have a properly working DNS server on your local network. Now, if you're on a Windows network, that means DNS is handled by Active Directory. If you're on a Linux network, it's up to you to configure DNS and make sure that it's working appropriately. If you're using pfSense or something else for your router distribution, you can configure a DNS service on pfSense. Most routers, you can configure manual entries in your DNS. And so you'll want to enable entries for your DNS for your server, but you'll actually want to assign your server multiple IP addresses. And it's like, well, wait, that doesn't make any sense. Why does assigning multiple IP addresses to the server matter? Why would that have anything to do with performance? Well, it has to do with the way that the network card chooses which queue to send stuff to. So it turns out that the network card actually has a couple of options for the algorithm that it uses to choose which receive queue it's going to dump the data into. Most of the time, it's a hash of the source IP address and some other information, mostly related to the source IP address and the destination IP address. So if you configure DNS to return multiple IP addresses for your server, and your server has multiple IP addresses, this is one of the easiest ways to make sure that the clients on your network randomly get a different IP address for your server. So what happens is if you've got 4 or 5 or 6 clients that are all hitting your server, when it says, hey, what was the IP address of server? When it does the lookup in DNS, it'll get one of the IPs that you've assigned to the server because you've set up the DNS entry to have the multiple IPs for the server. By doing that, it means that the network card is able to spread the load out of traffic across cores in the server because each different IP address is corresponding roughly to a different queue in memory that the network card is servicing. So that way you can spread the load across multiple cores. So we're going to take a look at doing that on Linux and FreeBSD and Windows Storage Server 2012. But in all 3 operating systems, doing this had a pretty big effect. Interestingly, with Active Directory and Windows Storage Server 2012, it was doing that out of the box. When we configured it, it was like, oh, I can just go ahead and assign multiple IP addresses. And when it assigned the interface multiple IP addresses on the server side of things, it automatically updated DNS, which is a function of Active Directory. And so when clients on the network would say, hey, what's the IP address of the server and let me connect, different clients in the network were already getting multiple different IP addresses, which helped spread the load across receive queues and send queues on the physical server. So that's one thing that you can do immediately to see if that improves performance or to do testing against, or something to be aware of. But we've got so much more to cover. Stay tuned for the next video in the series. And given the roadmap and given the plans that we've got, I want to hear from you guys. I want to hear from you in the forum at techsyndicate.com. I want to know what you've been through, especially if you're a network administrator and you've been dealing with 10 gigabit deployments and strange performance issues. And I had to deal with this crazy iSCSI thing where, you know, Max, the upgrade to Yosemite, just completely destroyed an iSCSI initiator. And then we had to turn off receive side scaling and some other craziness. I want to hear from you in the forums at techsyndicate.com. I'm Wendell, and I'm signing out to go troubleshoot more 10 gigabit stuff. But we're going to take a look, and it's going to be a lot of fun. See ya.